welcome to Ask the Lady Electrical Inspector podcast. I am your host, Tabatha L. Tonight, I will start part one for residential service requirements, Article 230 of the National Electrical Code. Tonight, I will give you a list of common electrical code violations that I have observed while performing residential electrical inspection on service meters and service panels. I will start with a question that I received. Is the choice between an overhead or underground new electrical service determined by the National Electrical Code? The answer is no. The National Electrical Code only sets the minimum requirements for underground or overhead service installations, meaning that if you choose to go overhead or underground, you have to meet the minimum requirements of that particular service, overhead or underground, and you will find those minimum requirements in Article 230. But to add to that question, if you wanted to know if you're building a new home, and the key word here is new, because that's the requirements for the National Electrical Code, new construction. If you're wanting to know whether you can go underground or overhead, you can contact your local municipality. You can go to City Hall of your local municipality or search your local municipality. For example, you could search Riverside, the City of Riverside Electrical Code Ordinance. And that will give you some instructions on whether or not you can go overhead or underground. Another way you can determine whether you can go underground or overhead in the area you're building a home or, well, tonight is residential or home, would be to check your local utility manual. So in this instance, you would go online, you would search whatever your local utility utility company is. For Missouri, you would put that utility company name in and put service manual. So that service manual will come up, and then you will look for the requirements. And I've done the homework for you all in the state of Missouri. So if you put that utility company name in, go to section 415.690 utilities. And I'll just give you a brief reading of what it says. All utility facilities, including but not limited to gas, water, sewer, electric, and phone cables, shall be located underground throughout any land development or subdivision. But as I stated, check your service manual, your utility service manual, to make sure what the requirements are. Also, in the utility service manual, service equipment, if you're going to do service equipment, they do have a section in there where it states that the service equipment is to be listed. And you find that information in section 300, and that's on page 44, bulletin 7. And it states equipment must be certified by an approved independent testing laboratory using the appropriate UL standard for certification. The utility company recognizes Underwriter Laboratory and ETL, Electrical Testing Laboratory, for equipment installed. So, as always, everything has to be listed, and even the utility company they want it to be listed. I'm going to describe an overhead service for you, just to get an idea and get a picture of what I'm speaking of when I'm telling you about the service of your home. So my explanation of it would be if you go outside and you look up and you look around your neighborhood or your community, and if you look around, if you see electrical cables just everywhere above your head, that means that your power, your electrical service is an overhead power service coming in. If you go to your meter box at your house and you look at that meter box, that's the utility meter box. If you look at it and you see a cable going up the wall or up the outside of the siding, that's what we call an overhead service drop. Now, if you're looking at that same meter box, and that meter box has a conduit that's going into the ground, that is what we refer to as a underground service. So I'm going to give you some wiring methods coming out of Article 230.43. And these are the common wiring methods you can use when you're doing a service, an overhead service. The most common wiring methods for overhead residential service risers are a rag cable. That's what we call, if you have seen those. SE cable, that's service entrance cable. Or you can use a raceway. That's just depending on the height requirements. If you can use a raceway, EMT, PVC, RMC. You can use one of those chosen wiring methods. Article 230, Part 2, overhead service conductors. The most common overhead service issues that I have experienced when I'm doing inspections. The first one I have experienced, and I see it often, would be a deteriorated service entrance cable or deteriorated conduit. So if I'm doing an inspection and I come and I see a cable that's deteriorated, and that means that the cable has just, throughout the course of nature, the jacket has opened or split, the sun cracked, or just the environment, the weather just deteriorated the cable. That's not a good thing to have for your incoming service, because for that reason, Article 110.7, the complete wiring installation shall be free from short circuits and ground faults. So that would be something that I would fail the inspection for, because the cable needs to be complete, a complete assembly of the jacket. The outside jacket, that's the protection of the inside conductors. So once that has been broken or deteriorated, now it must be replaced, because that's the first line of protection for your conductors. So if you're looking up at your home and you may see, if you see black conductors or even black conductors, or if you see copper, that means that should be replaced. You just need to replace that. Another thing that I've seen with service riser cables that I want to point out, SER cable. It cannot be used as a service riser cable because, as you know, SER cable is 4 conductors. Your service entrance cable only requires 3 conductors. And if you know those, what they are, you know why they're required. I've seen in the past where, I don't know why, but I've seen where a contractor may have that only on their truck. That may be something that they have on their truck that's left over and they want to get rid of it, but you can't use it in that application when you're going up to the service riser. So they would cut off a conductor put that cable in the meter box. That's not allowed. So you need a 3-conductor cable. You cannot cut the cable off and put it in the box. You need a SC cable. Okay. Clearance from the ground or the overhead driveway determines whether you would need a service mast. So that's Article 230.23. So when you have a service meter riser and it's, what that's saying, it's a minimum requirement that you have to meet when you install a service, and it's from the ground 10 feet to the bottom of that drip loop. And if you don't get that from your rag or your SE cable, now you would have to install a service riser, conduit, EMT, PVC, or RMC. So that's what I've also seen. Just make sure that you get your 10 feet. Article 230.26, point of attachment, permitted to be 10 feet, less than 10 feet above finished grade. So that's when you're required to do the service mast, as I stated. Also, in the your utility service manual, they have requirements for the point of attachment. And that you can find on page 6. Just a reminder, only the utility company can move the point of attachment. Another issue that I've come across often is guy wire. Article 230.28. You would require a guy wire for the mechanical strength caused by conductors, heavy weight from the flyers that's coming across from the utility poles if it's an overhead service. And another reason why you would need a guy wire would be if you put an offset in your conduit. If there's an offset in the conduit, that's where that phrase mechanical strength refers to. Because once you offset that metal pipe, or if you offset it, now you've broken down the integrity of that pipe. The strength is not as strong as a solid piece of pipe. So you would have to put a guy wire on the top of the offset, and then you would have to support the bottom of the offset with another support, just in case if you have any wind or anything that happens, if it flies away or if it becomes damaged, the guy wire hopefully will protect it from flying away or flying off. So I failed a lot of inspection because of missing guy wires. So with that, I would like to add the attachment conductors cannot be between the weatherhead and the coupling. So if you have a coupling, like if your riser is more than 10 feet and you had to put a coupling in there, so you put the coupling in, now you need a guy wire for that solid piece that's above that coupling, and then you need a support for the solid 10-foot piece. So that's when you are required to have a guy wire as well. The utility company manual on page 64, and you can find this information on page 129, states the weatherproof connector Myers hub. Anytime you install a raceway above an overcurrent protection, the raceway must be weatherproof to prevent leaks. Service entrance cable must be supported within 12 inches of the weatherhead or gooseneck at intervals of 30 inches. Now that's the NEC, Article 230.51A. So those are some common issues that I have had with overhead service risers. So now I want to go to Article 230, Part 3, underground services and the most common issues that I have with the underground services. So I'll start with one. Underground service requires bushings, even if it's PVC, because most likely that's what it is. So there's a misconception that if you have PVC conduit that you don't have to put a bushing on there. Well, I got support on that with the National Electrical Code, Article 230.230.32 and 300.5. You are required to have a bushing. Another issue, violation that I run across very, very often is missing expansion fittings. So the expansion fittings are required to compensate for thermal expansion, the deflection, and contraction from the Earth movement. That's Article 300.7b. So I'll explain that a little bit. So if you have underground service conduit, and that service conduit enters out of the ground in a dirt area or gravel, you're required to put an expansion fitting there. Now, if you have a concrete pad, you don't need an expansion fitting because it's not going to move. It's solid. But the earth is very unsettled, so we have to allow for that expansion to go in and out in the contraction. Another thing that I often fail inspections for is shallow trench. And you can get that information from the depths from table 300.5 to make sure that your depths when you're doing any underground work. But in this instance, for underground services, it would be 18 inches. I'll just give you that information. Depending on if you're going over a roadway, because there are different requirements. So depending on what you're doing, just look it up and see if you meet that depth requirement. Here's another one that I have. HDPE, high density polyethylene raceways. So that's a raceway that is only allowed to go underground. And when it's underground, it can't emerge from the ground. It has to stay in the ground. So now you're required to have a transition fitting. Because if you're coming from underground, you're going to have PVC. So that transition fitting, it must transition from the HDPE, high density polyethylene raceway, to a PVC raceway. And there is only one listed coupler that I know of that I've ever seen in the industry that's listed, that's allowed. Because this raceway acts as a barrier to prevent the wires from any chemical or contaminants underground. And where you can get that information to verify that this fitting must be listed, you can go to Article 353.6 and check the listing requirements. So I'm going to give you some common voltages for residential homes. The common voltage would be 120, 240. With special permission and just the requirements that you're going to have in your home, like it just depends on what you're going to be feeding in your home. I have done inspections on three-phase homes, but those requirements, those homes are really extensive and they have a lot going on there. But to get 3 phases of power for a residential, you have to get special permission from that utility company. So the common amps on most homes are 100, 200, 400, and 600. It can go up to 8, 1,000, but those are going to be really large homes. Okay, so I have outlined a few of the most common electrical code violations I've found while performing an inspection on service meters. Missing premise numbers or inaccurate premise numbers. So you may ask yourself, well, what's a premise number? The electrical contractor know what they are. A premise number is a number you have to get from the utility company. So anytime you're going to do a service, you have to call the utility company and ask them for a premise number. And the reason being, they want to know everything that's going on, the electric, because they are the facility that will provide the electric for you. So that premise number is very important, because if you have one digit off, it will not go through. They will kick it back out, and you will have to have the correct premise number and the correct amount of numbers, which would be a 9-digit number. So that's one of the main problems that I have when I'm doing a service inspection. You have to have the correct premise number. A question I get often from the contractors, they would ask me, do I need a bypass meter? Is it required? Well, I looked into that because at one point we were requiring it. But now you would just go to page 145 of your utility manual, and it will state whether you need a bypass meter. It gives some requirements of when they are required. So page 145. Here's another one, a weatherproof connector, a Myers hub. Anytime you install a raceway above an overcurrent protection, the raceway must be protected from the weather to prevent leaks. So Article 314.15, damp and wet locations to prevent moisture from entering or accumulating within the meter. Article 300.15, it tells you the connectors that you can use. They must be specific to the wiring method for which they are designed or listed. Article 250.92b, concentric knockouts. At the service meter, I have had not a problem, but that has been a code violation when you're installing a metal raceway. So if you're installing a metal raceway and you have that concentric knockout, you would have to put a bonding bushing. That's where the Article 250.92b fall in, because the concentrics on the meter can starts off like at 1/2 inch, 3/4, 1 inch, and it goes all the way to 4 inch. So if you knock it out at 2 inches, you're going to have an opening that's around there and it's not sealed. So you need a bonding bushing to bond that concentric knockout. You would need a bonding bushing. That's required on any metal raceway where you're using a concentric knockout. Another issue that I have often at the meter can, unused openings. So if you knock out an opening and then you decide, oh, I don't need that, you must install what we call a KO enclosure. That's required. You can find that information, Article 312.5, because the KO enclosure is going to protect the integrity of that box. Because remember, you do not want any water to accumulate in there or any outside anything. You don't want anything inside of that box, because I've seen it where you take off the cover, and then there could be a bird nest inside of your service meter. So the reason why you don't want things like that inside water or anything foreign inside of your service meter is because you want it to safely operate. And how we protect that is to not allow anything inside that meter can. So that's anything. You don't want water. You don't want moisture. You don't want birds' nests. You don't want dirt. You really don't want anything inside of there, because if over the time it can accumulate and then cause it to malfunction. And then that's going to be a expense that you could have saved yourself just by keeping those openings closed. Working clearance. So with the service meter, working clearance is required. So how do you know what the working clearance would be? You would go to Article 110.26A1, and it will give you the requirements for the working clearance. So with the meters, you don't want anything to obstruct the front of the meter. And the most common things that I find that obstruct the front of the meter, because you need a working clearance in front of that meter of 3 feet. I'll just tell you that information, 3 feet, because you want to make sure that if the electrician or if the utility person has to come there and they have to work in front of that meter, you want them to have working clearance where they can safely work on that meter without anything obstructing them in the back of them, where if anything happens, they will be protected and nothing will obstruct them from getting out of the way. So one of the things that I find often in these cases would be AC units, like the air conditioning units. So when you're going to look at a service or you're installing a brand new service, just remember nothing can be in front of it. So if you see the AC unit that's directly in front of the meter can, bump your meter over, because it's not going to pass. That's a requirement out of the National Electrical Code, and that's a utility requirement, because they want to make sure that everyone is safe in that situation. I've seen this on service meters, the panels, where another obstruction could be a fence or a gate. So you can't have anything there, or another house. Like if, for whatever reason, if your house is over, if you didn't have a neighbor and then that neighbor build a house next door to you and your meter's on that side of the house, of that side where the brand new house is going up, you have to have a working clearance of 3 feet. Now, I know you can't control where they start their land, but now if they do start it where you're not going to have your clearance, you need to call the utility company out, and that will have to be moved eventually. And you're probably not going to catch that. We're not going to catch that until you go to do a REOC inspection, and then that's when that probably will become an issue. Now, another thing I'm going to state with that fence or gate is to take into consideration whether you're on somebody else's property line, because I've had that before where the contractor installed a meter, but there was a gate there. Now, that gate or that fence, it was the neighbor's fence. So now you have to go around their fence, go on to their property to get to that meter, and that's not allowed. So just want to put that out there because I have had that before. So CT, current transformer cabinets, are required on all 120, 240 services over 400 continuous and larger. The utility require that as well. The utility companies, they require that as well. You can find that in section 1001, page 161. With the CT cans, spoken to several contractors about this, so I got the answer for you, where you can find it, because it's not a national code issue. It's something that the utility, they require. When you're in that CT can, they want it bonded. And you can find that on page 51, note 3. The grounded neutral must be bonded to the CT can. So electrical contractors and electricians, you know what that means. So that's not a national electrical thing. Just want to make sure we understand each other. That's a utility requirement. So All the service equipment shall be bonded together per the latest edition of the National Electrical Code. And for us, it's in the first disconnect. The first means of disconnect. That's where we bond everything at. But at the utility company, they do require that. Supplementary ground rods must be flush to the ground to prevent trip hazards if installed in a driveway. I've seen that a few times. That means that there's probably maybe a couple inches that are sticking up. So if you know you can't get it flush to the ground, try to find the location in a dirt or soil to try to embed it in that dirt or soil to get it flush as possible, or out of the way, closer to the wall of that driveway or something, because that's going to be a trip hazard and it's going to be a problem. And you cannot cut it off. I've had that question asked. Can I cut it off? No. The supplementary ground rod. Okay, so the multi-unit. If you have an apartment complex, all the apartment complex meters and panels must be labeled. And that's per Article 230.70B. On both sides must be labeled. The supplementary ground rod shall not be required to be any larger than a number 6 odd. The supplementary ground rod must be flush to the ground, like I mentioned, to protect against physical damage as well, like a lawnmower if you are in the grass. You don't want anything to damage that grounding electrode, because if you hit it around a few times or a car run over it a few times, it's going to become loosened. And if the conductor come off, the grounding electrode comes off, it's not going to serve its purpose. So that's one less form of grounding that you would have in your house to offer your electrical system protection. So make sure you're paying attention to that. If you're mowing your lawn and you see a copper rod sticking out, try not to run that over, because that's really important for your safe operations of your electrical system. With that being said, we're in the driveway. So when you come out of that service meter and you're in the driveway, if you're in the driveway, that means that your car can come up and hit that service equipment or run into that cable if possible. Just depends on the height, because there's height requirements with meters as well. So the one thing that I have often, I have the service entrance cable running down the side of the house, and then it pokes into the house. So if you have that situation where it's possible that it could be physically damaged, you need to, what we call a car line boot. It's like a half PVC channel. So that needs to be installed to protect it against physical damage. That's one way to protect it. Now, if you have an underground, like if you came out of the bottom of the meter and you're running PVC, the PVC Schedule 80 has a inside, the diameter inside is a little bit thicker than Schedule 40. So if you know that you can't protect it against physical damage, use Schedule 80 PVC. That's allowed in the code book. So the articles that will support the cables being physically protected would be Article 250.50B, Article 110.27B, location, driveways, or apartment complex. All right, so I have outlined a few of the most common electrical issues I find while performing an inspection on service panels. Now we're in the house. We left the outside of the house with the service meter. We're in the house at the service panel. When to bond the neutral and the equipment grounding conductor. So one thing I want to go back on when I talk about that SR cable. You are allowed to use it if you're coming out of the bottom of, if you have a what we call a meter combo can. So that's your first means of disconnect outside. If you have a meter and then you have a main disconnect breaker outside. So that's your first means of disconnect. Now you can use your SER cable because it's 4 conductors. And the electricians, they know what that means. So the panel inside now becomes your sub panel. I'll get into that a little later. Just want to give you a reason on when you can use SER cable, because when you need to carry 4 conductors. So the service panel, it must be bonded in accordance with 250.24. 4. Premise wiring supplied by a AC service must be connected to a service neutral by a bonding jumper or a bus bar. So Article 250.142A1, it says on the supply side or within the enclosure. So these are articles where you look into the code to find on the bonding together. And you should know what I mean by that. The service panel or the sub panel. So here's something. So if you have, I don't want to name, I'll just say it like this. Service panels are required to have all of the same breakers, whoever the manufacturers are. Most manufacturers do not allow different manufacturers' breakers in their panels. It's like a licensing thing. They want to make sure that those breakers fit. Because if you try to use a different manufacturer breaker in certain panels, it's not going to work. It's not going to fit, and it's dangerous. So if I come to a panel and I see that company name, and then I see that manufacturer's name, and then I see different breakers in there, I know immediately something's wrong. Now, there are a few manufacturers that will allow you to interchange their breakers, but you need to look that information up. There are a few, depending on the manufacturer. You need to look that information up and make sure you're using the right type of breaker. And if you know you're not using the correct breaker, make sure you have that information on site when the electrical inspector comes, because we're going to ask that question, because that's a red flag. We got to make sure that the breakers are all the same and that it functions properly. I have that quite often. So where you can get the support for that article is Article 110.3b. Listed and label equipment shall be installed in accordance with instructions of the listing and labels. So we're still inside at the service panel. Here's one. I may have this issue, I'm going to say maybe twice a week on an average. Go inside, you got to look at the service panel. If I got to pull out a flashlight to examine the service panel, to inspect the service panel, you need a light there. Now, I get this often. Well, I got an article for you. 110.26 illuminations shall be provided for all service equipment, switchboard panels, motor control centers, any place you have service work or any place you have anything you have to work on that has to do with electrical. I have that, because if you have to pull out a flashlight to see what you're doing, you need a light there, a lighting outlet. I just had this one. This is personal for me. That's why I wanted to bring it up. Bonding jumper around the removal devices such as a water meter. So a bonding jumper is required if you have a removable water meter in your house. But how you can avoid avoid that jumper would be to go to the street side. Just bypass the meter, that removable device, bypass it, and go straight to the meter, the incoming side of that water, because the main grounding electrode has to terminate within 5 feet of the incoming water line. Now, most homes have a meter which is really monitoring the water flow, and if it's removed, that's like an open circuit. So that's what the bonding jumper is for. If you remove that device, the bonding jumper acts as the meter that's removed to be replaced. But if you bypass it with your water grounding electrode conductor, it's the same difference. So you can find that Article 250.53D1. The main water grounding electrode conductor must be accessible. That's Article 250.68A. Here's a misconception. The outside supplementary grounding rod that I spoke of, you don't want to run it over. You don't want to run it over with a lawnmower or car. The misconception is that has to be accessible. That clamp that's on there has to be accessible. That's not true. The only thing that needs to be accessible, because that actually can be buried in concrete. You don't have to remove that clamp. You have to have accessibility to the water. And the reason being is because of that removable device. Any electrical equipment that has cables or anything, conductors, boxes or anything, has to be accessible. So that's why the main grounding water electrode must be accessible in the house, not the clamp outside in the ground, not the supplementary. It can be buried. Sometimes I have issues with the sizing of the grounding electrode conductor. To get the sizing correct, go to Article 250.66, and it will tell you. And how you determine that is the service insurance cable conductor size. That's how you read that chart. So if you have, depending on the service entrance cable, the ungrounded service entrance cable conductors, you read that chart and it'll tell you what size to run for a 100 amp service, 200 amp service, but you're going to size it according to the service conductors, the size of that. Whether it's 2-aught, 4-aught, copper or aluminum, don't make that mistake. That chart will tell you. Matter of fact, I'm just going to grab the book and give you examples. Okay. So here we go. 250.66 grounding electrode. This is the one that's coming from the main panel going to the water. So size it the size of the largest ungrounded conductor or equivalent. That means add it up. If you got parallel feeders, you got to add those all up, and that you will come up with your size of your grounding electrode conductor. You got copper, aluminum, or copper-clad aluminum. So if you look there, it'll tell you, and you have to go between these, the numbers. If you got 2-aught or 3-aught, just look, but make sure you get the correct one, whether you're running a copper grounding electrode or aluminum. That's required. Another issue I have in service panel, double lug neutrals. A neutral conductor is you're only required to terminate one neutral conductor in a terminal. One per terminal. Because think about that. If you do two and they're both under that terminal lug, and if you go to remove one and it's a multi-circuit, and you remove one but accidentally remove two, now you got 120 plus 120. We know what that is, and that's going to be a disaster. So one neutral conductor per terminal lug. You can double up on the grounds. But you also got to read the instructions on that too, because it tells you how many you can get in there. Okay. So this is something that I've had issues with recently. I'm going to go back to that meter panel combo enclosure. If you get a separately derived system, such as a solar panel on your house, in this instance, because of the pitch of the roof, now certain roofs, they're not going to allow you to put a solar panel on. It's the pitch of the roof. I don't know all of those requirements because I'm not a building inspector. So if you get a solar panel and you have to put it on a detached part of your house, like a garage, in this instance, it was a garage. So you would have to call the utility company out, because now you have one service at your house. You're going to add a separately derived system, solar panel, and you're going to put that solar panels and the meter ring on the detached garage. But you have water, your main water, because for the jurisdiction that we're in, we're residential. There's two main grounding electrodes that you must have. Supplementary ground rod, that's the ground rod we spoke about that's in the ground, and the main water ground that's in the house. Now think about it. If you are detached from your house and you're putting a separately derived system at your garage, you have to pick up that water. How do you do that? That's one thing. So don't forget, when you're running your conduit out there, to compensate for that water ground. And another main thing, this is probably for the industry, it's a separately derived system. So you're starting over with your power. You have to have a disconnect out there. Because as I mentioned, the code do not expect for you to run in the house to disconnect anything out there in that garage. So if you have, if you're going to install a solar panel, keep those two things in mind. Add a disconnect out there, even if the print, don't call for it, because I've had this over 5 times where it wasn't on the print. And that's what the electrician argument was. It's not on the print. It's required. So keep that in mind when you're doing solar panel systems on detached structures. It doesn't necessarily have to be a garage, but if it's detached from the house, meaning it has no attachment, no roof, or anything that's touching the house, it has to have main water grounding electrode and a disconnect. Okay, I'm going to end this with a question that I received. If an electrical contractor installed a service meter only, just the meter outside, why is it mandatory for the electrical inspector to go inside the residence? Okay. Well, to check both sides, that's mandatory on our side. We are instructed to make sure that we check both sides. So one reason why we want to go inside, we want to go in to check to make sure you don't have open conductors. Because I've had that where the contractor, for whatever reason, the SC cable or the conductors were coiled up, open conductors, and they hadn't landed yet. And then you call them up, and they say, oh, I had an emergency, had to run somewhere. But had you not gone inside and you sent the utility company to energize that service, that's a disaster. So that's one reason why we must go inside. And also to perform, if you didn't do the service panel inside, we still want to know what it looked like inside. That's a courtesy to you, because I know that a lot of contractors, if they do one side, they don't worry about the other side. You should, because overall, you're putting your license on it. You don't know what's in that panel if you don't look inside, so you should look inside, because that's where I find a lot of problems when you only do one side. I come in and I see a rat's nest inside that panel. I see double lug neutrals, cables everywhere, different breakers. It's a lot going on in that panel. So we're just giving the homeowner and the contractor a courtesy inspection. Now, if you only did one side, which would be the meter outside, and you didn't do anything with the panel inside, that code issue wouldn't go to you. It would go to the homeowner. That would be something that they would have to correct. But how it would affect the contractor is your permit can't be closed or passed. We'll put it on hold for you until that issue is taken care of. So that's something you need to consider when you're going to bid jobs. Make sure that inside panel looks good as well. And we go inside to make sure that the permit information is correct and that you only change one side. Because I've had that issue a couple times where they only changed the service meter, but then when I go on inside, I see a brand new panel. So now I got to ask the contractor, this panel is brand new. You said you only did one side. So sometimes they'll say, well, I only did one side. So I say, well, this panel is new. How do you account for it? So that can turn into an issue, just depending. But we just want to make sure that the contractor is, the scope of work that he put on the permit is correct, and that we have correct and accurate information. Another reason why we go inside the house, we need to go inside the house, is because inspection has passed. Now you need proof that the inspection passed. So we have a final sticker for completion that we will put in the panel, and that will tell the next inspector or whoever else comes in the house after us, because if you have a REOC inspection and it's pending a final electrical inspection, they would need to know what passed. And if they don't see that sticker, they know, hey, I need to call that inspector to see what's going on. That's proof that your inspection passed. So that's reasons why we go inside, just to check both sides. So if you have any questions or comments, please contact me on any of the social media pages, Facebook, Instagram, X, YouTube, under the moniker Ask the Lady Electrical Inspector. If you would like to add to any of this discussion or provide feedback, you can email me at askthelady.electricalinspector@gmail.com with any questions or electrical concerns. Thank you and have a great evening.